Hey guys, this is going to be another quick Linux command video. Check the link in the description for more info and for copy and paste examples. The Linux kill command is used to send signals to processes. The default signal is term. Now, sending the term signal to a process will usually kill the process unless that process has logic to catch the signal. So basically what the kill command does is it's basically just used to send signals to processes, but most of the time when you do this manually, you're sending a signal that will kill the process. One of several different signals can kill processes, but sometimes you'll send signals to have the processes do other things, to tell them to like reload their configuration or something along those lines. Now, let's see what's running here. So I don't have anything that I specifically want to kill, but let's say if I'm going to make sure something is up and running in another terminal. I'm going to start up a process that we can kill. So I'm just going to run top in another terminal. We're going to search for top, right? Now, you see here we have the top command running, right? So if you want to kill that, you can say kill and copy the PID. This is the PID for the top command that I'm running in another terminal off screen. So send kill to it, and it was killed, right? So we're gonna grep for that top command, and yeah, so we don't see it running. We have a few other things that match top, so anything with desktop as the word top in it, but the top command was killed, right? So now you could also, let's see here, I'm going to start up a few of them to show you the next example. So let's start up 3 of these running in the background, and let's just grep for top. Now see, we see 3 versions of top running. Now say if you want to kill all 3 of these, you could say kill. Now there are other ways to do this, but we're doing it this way just to show you how the command works for today. So copy this, paste it in there, copy this. There are slicker ways to do this, but we're just showing you how the top command works, right? So you can kill all 3 of these processes, and all 3 of them died, right? So when we check if they're running, all gone. So no top commands running. We can see I'm grepping for top and see some things with other matching names, but there you go. We've killed all of those, right? Now let's say if we start one up again, and let's just check, right? We can see this is running in the background. Now, let's say if this responds to just a kill, so sending the term signal, but if we wanted, we could say, kill. So some processes will catch the term signal and they'll wait and they'll do some cleanup. They might save log files or clear some variables out, whatever they close connections to files, things like that. Do some cleanup before then shutting themselves down, or they may just completely ignore you. So if something's ignoring you, or you want to force something to shut down right now without giving it the option to do anything else, you can do a kill-9, right? Now the kill-9 is the number of the signal, so it will send a sig kill, which will terminate the process, and this signal cannot be caught, so it won't give it a chance to clean up or anything else. It will just basically force kill the process. This is when you don't want to be gentle and you want to force kill a process. You can use a kill-9. So the reason we didn't specify the actual number, we just kill, is because term is the default. So sig term is signal number 15, so we could have specified a 15, and that would be the same as not specifying a signal. But this is the signal right here, a number 9. So this is the common usage of the command. You'd say kill-9 and the process name, and that kills it. Now the most common usages, and let's just verify it is in fact killed, right? So 2 most common uses of the kill command are going to be either kill-9 to force something to die, or gently kill it with just a kill. So you can say kill or kill-9. Those are going to be the most common use cases for the kill command that you're going to use almost ever. So almost always you're doing that. Another common signal, and we're going to get into what each signal is, but another common signal that you're going to use, the third signal, so basically 3 signals, sig term, so sig term, sig kill, and we're going to do sig hop or sig hang up. This is a name that comes from the old days when you would have an actual remote terminal over a modem or whatever, and this would signify that the connection was hung up or something along those lines. That's not relevant today. And the default behavior is to terminate, but for some processes like certain daemons and stuff, they will catch this signal and they will reload their configuration. So if you happen to be familiar with a specific daemon like a web server or whatever else, and you know it handles this, you can use sig hup, which is a -1. So you can use your -1 and send a sig hup to a process. So if this were the PID of the process, you could run kill -1 to send a sig hup, and if it does handle it and do this, it might just reload the configuration files and configs without shutting the process down, or it may shut down and start back up and reload the configs, however it's configured to work. But that is one thing to be aware of. Now, another way of specifying these, instead of specifying them by number, so you could say kill instead of kill -1, you could say kill HUP. Now the actual signal name as it's listed, we're going to show you the table in a minute, is sig hup, like this, sig hup. But so there's in the front of every signal at the beginning of the name is SIG for sig, but generally you don't specify it by sig hup. You would specify it by just hup. You exclude the sig part of the signal, right? So you'd say hup, and put the whatever your PID is here, 149.873. That's not an actual running process now, but this is how you'd specify sig hup if this happened to be like a server that you want to reread its configs, and that's how that server behaves, right? So you could also have done just to send the default was term, so you could do sig term like this, or you could do sig kill like this. That's the kill -9. Normally you're not going to, the most common use case is just to use the default, if you want sig term, or a -9 if you want sig kill to force kill it. If you want hup, normally I've seen people actually specify hup like this, but you could just specify 1 like that if you want. So anyways, that's worth being aware of, and it's nice to have a little, one thing, you can also use kill -L, and this will display all of the signals like this. And notice the names have sig at the beginning, but if you want to specify them by name, you won't specify a sig. You would just say hup or segv. This is something you wouldn't normally send to a process. This just signifies that there was a segmentation violation and the program tried to access memory that it's not supposed to, and this will kill the program. You could send that by hand if you wanted to, but generally you don't, right? So this gives all of these, and you can specify them by number. Like sig hup, you could specify 1, or you could just say hup, whichever you want, right? Now, like a kill -9, sig kill, you can specify a -9 or a -kill, either one you like, right? So that's how that works. These are all the signals. And now I'm going to cut away to a big table and talk about these signals for just a quick little bit here. All right, so right here, hopefully this is zoomed in enough to be able to read it, but let's just go over the signals real quick. These are the notable ones. So let's take a look at the top here. Now, signal 0. This is missing from a lot of documentation, but basically does nothing, no signal sent. It still does error checking, so it may check if the proc is running, and it's often not listed in documentation. So if something's wrong and you can't send a signal to the process, then it'll give you an error. So it does error checking, but it doesn't really send a real signal to the process. Now, sig hup, default behavior. So this column is default behavior, and this is the description, right? So sig hup, terminate. So signal hang up means the controlling terminal is closed and will cause some daemons to restart and reread configs. Now, sig int, terminate. So interrupt causes the process to terminate, can be ignored or caught, allowing cleanup, etc. Now, this is usually what happens when you type Control-C on a keyboard. That usually does, it interrupts the process and terminates it. Now, sig quit will terminate and core dump. terminates the process and creates a core dump. Now a control, control backslash or whatever here, yeah, that will usually cause this to happen if the process is in the foreground and you're on the terminal with it. Now sig ill, it will terminate in core dump, sent to a process when it attempts to execute an illegal, malformed, unknown, or privileged instruction. So sig trap, terminate in core dump. This is sent to a process when traps occur. So, for example, the debugger wants to be informed of, something the debugger wants to be informed of, it sends this signal. Not going to elaborate too much more on that one specifically. That's more like a topic for another day. But sig abort will terminate in core dump yet again. Tell a process to terminate, usually sent by itself using the abort call, but it can come from other processes. So yeah, process can send itself a signal. So generally, if you want to force a process to core dump, you could send it a sig quit. I guess that's a takeaway there. Now, what else? So sig bus, terminate in core dump, send to a process when it causes a bus error. So as an example, incorrect memory access alignment or non-existing physical address, that can cause this signal to be sent. So a lot of times these aren't manual signals you're going to be sending by hand. They're things sent from either the system or another process or something like that. So sig FPE, terminate in core dump. It's exceptional but not necessary. Early erroneous condition has been detected in the floating point or integer arithmetic hardware. So I think that may or may not include dividing by 0. But anyways, 9 is sig kill. This will terminate. Kill, terminate immediately, can't be caught or ignored. Procs can't clean up. Now exceptions to this might be a zombie process or something that's blocked, or the init process won't take this signal, and or if something is uninterruptedly sleeping. So you can't always kill every process, but this is basically the force kill signal. Sig USR, terminate, and its behavior is user defined. Sig segv, terminate in core dump. It is invalid memory reference, segmentation fault, segmentation violation. So sig USR2, terminate, it's another user defined one. Sig pipe, terminate, and write on a pipe with, so this can happen if there's a write on a pipe with no one to read it. If you write to a pipe but there's no one to read it, you get a sig pipe. So sig alarm, terminate an alarm clock. Not sure how that works, but this is what this is for. Sig term, terminate, request process termination, can be ignored or caught, allowing for cleanup, etc. This is the default signal sent by the kill command. So sig STKFLT, not applicable. So this is coprocessor coprocessor experiences a stack fault. Now, notable thing, this is not a Linux thing, and the focus of this video is Linux and the Linux, the Linux kill commands. So this would be more like on other systems, whether they be, I don't know, either BSD, Solaris, IRIX, HPUX, AIX, something like that. Some of those may or may not use this signal. So sig child, basically default behavior is ignore, and then this is sent when a child process terminates. Sig cont, continue. So this will start a process back up after it was stopped or paused. So when you bring a process back into the foreground, or start it running in the background after you had paused it, that's what that does. Now sig stop the sig stop signal instructs the operating system to stop a process for later resumption, basically pauses it, right? Now, sig STP, stop, terminal stop, causes a process to suspend execution. This is what happens when you type Control-Z on the terminal with a process in the foreground. Now, sig TIN will stop background this is if there's a background process attempting to read. Now, sig TTOU, stop background process attempting to write. Sig URG will ignore. This is out of band data. So out of band data is available at a socket. So SIG X CPU will terminate in core dump. CPU time limit exceeded. Same thing for SIG XFSZ, another terminate core dump, but this is for file size limit exceeded. Now SIG VT alarm, terminate, virtual timer expired. SIG prof, terminate, profiling timer expired. SIG WINCH, default is to ignore. This is window size changed. Now SIG IO, unclear about the default behavior. It's SIG IO is a signal that is sent when normal data, out of band data, error condition occurs, or just about anything happens on any type of socket. SIG power, so sent on power failure. Not sure how that works, but that's what this is listed as. SIG sys will terminate in core dump. A bad argument sent to a system call, rare because normally programs don't call system calls directly. Normally they would be called from libraries, which are generally going to be a whole lot more stable. So yeah, this is a rare one, but that's what this is for. Now SIG RT min is so this is user defined real-time signal, and same thing for SIG RT max. It's another user defined real-time signal. So and you can see here, here's my terminal again, and you will see that yeah. So see how we had SIG RT, so RT min and RT max. You have a bunch of plus or minus different values. So I didn't document those because they're basically almost the exact same thing. So that is why I stopped at around 34 and then went up to 64 and then stopped there. So yeah, just to be aware of that. And yeah, 64 right here, right? So yeah, that this is what these are all the signals that might be sent. That's about everything I wanted to cover for, and this is the document that's listed in the description of this video, so check that out if you want. I put this table together from a bunch of different sources and kind of I tweaked it a bit so it makes sense. You can get a lot of this info easily other places if you Google the kill command or Linux signals, but it's not going to be exactly how I displayed it here. I found this to be the most useful, but there it is. So anyways, that's everything I wanted to cover for the kill command for today. Check the links in the description for more info. Hit the subscribe button for more useful content like this. We also have a ton of other more interesting content covering things like coding, hardware, software, servers, Raspberry Pis, 3D printing, and a whole lot more. Hopefully you found this useful. Thanks for watching, and we'll see you guys on that next video.